Hello guys, so welcome back to our lecture 19. We're gonna start in this recording about another transistor, which is basically the sibling of the NPN transistor, which is basically PNP transistor. So basically it's a transistor, it's also bijunctions. There are two junctions, G1, G2, just like the NPN, but now they are flipped. So what was N become B, what was B become N. So it's basically the emitter is B type. The base is N type, and basically the collector is B type. So it's PNP. But again, the emitter is still highly doped than the other ones. Okay. And still the base is, a thin layer between both. So basically it's the same operation. Okay. So let's explore the operation, for example, in the active region. So in the active region, again, we want G1 to be forward, the junction between the base and the emitter. And we want, again, the junction between the collector and the base to be reverse. So G1 between base and the emitter should be forward and on. G2 between base and the collector should be off. For this reason, VEB, not VBE, because E now is the base, is the B type, and the base is the N type. Okay, so VEB should be 0.7, and VCB, the voltage of the second junction J2 between the base, which is N type, and the collector, which is N type, VCB, should be less than 0.4. Okay. It might be forward, but with a very small voltage so that it still can be considered off. Again, to remind you, any junction, the voltage and the current of any junction is related with such exponential relation. So between 0.4, it can be considered off, or the current, approximately 0. Here is G1. Here is G2. Okay, and look at the batteries. They are flipped as well. So VEB is in that way, so that the J1 should be forward and on, and VEC between the collector and the emitter is that way. It's also flipped, so that the junction between the base and the collector, can be controlled to be off. Okay. How about the current? Again, since there is an on junction between the base and the emitter, there will be a flow of holes this time from the emitter to the base. And there is, little electrons from the base to the emitter. Again, why is this? Because the doping in the emitter is very high, and also its distance, its volume is, larger than the base. So it's larger than in volume, and also larger than or greater than in number of current carriers. In this time, it's holes in the emitter and electrons in the base. Remember, the current is opposite to the direction of the electrons and with the same direction of the holes. So there will be a current in that way due to the holes, IH, and another current in that way, IN or IE, whatever you call it. Look, IE is different, is opposite to the motion of the direction of the electrons. Okay. Then, since J2 is reverse, we studied this in our first lecture in transistor. It's like we are injecting carriers into a reverse bias junction. So they just flow toward, you know, the negative terminal here, which is connected to the negative terminal of the battery. And of course, holes, you know, are attracted to this. And this is the base current will just flow in that direction, as you see. And this collector current will flow in that direction, as you see. So this is IB, this is IC. And again, they will be, you know, joined again at the emitter. That's why again IE equal to IC plus IB. But now it's in opposite direction. So now IB going out of the base. IC is going out of the collector. And IE is going into the emitter. They are very opposite to the NBN. So they are positive with these directions. And here is, you know, the symbol for the PNP transistor. Since the emitter current is going into the collector, the letter arrow here, which discriminate, you know, the emitter from other terminals, is going into. This is basically the emitter. So that would be the base, that would be the collector. And of course, in active region as well, you will find that IC is equal to beta IB. No doubt on that. And for saturation now, I think we can conclude or derive the same equations, but just look at, you know, the flipping of the voltages. So in the saturation region, we will have something similar, exactly similar to the, you know, the NBN transistor. So basically J1 and J2 both will be common. VEB will be still 0.7. And VEC now will become 0.2. So it was VCE before. Now it's VEC, 0.2. It's still IE equal to IC plus IB. But now IC over IB is less than or equal to beta. That's basically the second region. The last region, which is the cutoff. Basically, everything is zero. IE equal to IC equal to IB equal to 0. Why? Because both junctions are off. So J1 and J2 are off. Again, off means one of them might be, or even both, might be forward, but with very small voltage, less than 0.7. That's why they will not turn into, you know, on. They will have negligible currents, we can say. Okay. So it's basically same as NBN, exactly the same, but we just flipped the directions of either voltages or even the currents. Everything is flipped here. Okay, let's take an example. Here is, you know, a small example. We have two resistors, RA and RC, and remember the flipping of the transistor. So E here is drawn, you know, upward toward the, you know, the highest voltage in the circuit, and the collector is toward the lowest or the minimum voltage in the circuit. And here is the base, and the beta is 100. Find everything. This is a normal, you know, question. You just given, you know, a circuit with every information in it, and just find everything. Find every current, IC, IB, IE, VCE or VEC in that case, and the VEB as well. Again, we're gonna follow the same procedure. So we're gonna assume active. Why? Because there is a source that can give the VEB this time, because this is PNP transistor, the 0.7. Where is that source? Just to draw the battery, the 10-volt battery. So that that is the 10-volt battery. Where is VEB? It is in that direction, opposite to the battery. So yes, there is a source, and in that loop, that source can give the 0.7 so V, because it's basically greater than 0.7. This is VEB here. So we're gonna assume that VEB is 0.7 volt. This is IE. It's a good practice here to put the current before anything, because you might, while going into the solution, you might mess up with, or confused with the NBN, and assume an opposite direction for the current. So it's important to start with the current directions. So IE is going into, and remember you have here a clue because of this small arrow here in the symbol. IB is going out of the base. IC is going out of the collector. Okay, good. So let's do KVL here. So in that loop we have 10 equal to 0.7 plus IE RE. Remember, RE is known, so basically you can determine here IE. So IE equal to 4.65 milliamperes. Beta is 100. Again, IC equal to beta over beta plus 1, which IE, which is called alpha IE. Since beta is 100, 100 over 100, 101 is basically approximately 1. It's 0.99. So basically, it's approximately equal to IE, 4.65. And you can determine IB if you want. IB basically will be IC over 100, which is beta, so 0.0465 milliamperes, or 46.5 microamperes, whatever you like. Now we should determine VB and VC to compare them, to check that really J2, the junction between the collector and the base, is reverse bias. This is very important. So how we can calculate VB? Let's check. Here is the base. The base basically is connected to the ground, which is really nice. So VB is equal to 0. Now VC, here is VC. So this is, the collector here. So we can draw this like this battery. We can draw it like this. It's -10 here. So, and the current is flowing in that direction. So the voltage is so this is ICRC, and this is the battery -10. So both are in the same direction. So VC is equal to -10 plus ICRC. IC is known, RC is 1 kilo ohm. So -10 plus 4.65 milli multiplied by 1 kilo. Kilo will cancel milli. So you have -10 minus 4 plus 4.65. It is basically 5.35 volt. Good. Remember, the base is in. So this is minus. I'm sorry, this is minus. Yeah. So minus, because -10 and plus 4.65. This is minus. Remember, the base is B type or N type. I'm sorry, N type. And it's connected to 0. And the collector is basically B type. And it's connected to a negative voltage. So the voltage on the base, which is N, is greater than the voltage on the collector, which is B. So it's a reverse bias junction. Or you can say that VCB, VC minus VB, equal to -5.3 minus 0, it's -5. So this is less than 0, so it's so J2 is reverse basically. And the assumption is correct. Okay, guys, this is basically, an example for an active region operating PNP transistor. In the next lecture, we're gonna check, another circuit but this time we're gonna see how the PNP will be analyzed in saturation region. It will be basically the same as NBN, but just to train ourselves. Thank you very much for watching this video, and see you in the next video. Bye bye.